Right? So just so you know, this is the difference between a vertical asymptote and a hole, right? A vertical asymptote is this dashed red line on the graph. That is a point of discontinuity because if I was drawing the graph, I would have to pick up my pen, move it over to the other branch, and continue to draw. Right? The hole is actually a little open circle in the middle of the graph, which means exactly at that one point, there is actually no value of the function. So if I was drawing this, I actually would have to pick up my pen, move it to the other side, and keep going. So notice the difference in terms of what you see on the graph. Where you see a vertical asymptote, because the graph is approaching that line and getting infinitely close, it must be veering off towards negative infinity or positive infinity. Or in this case, in the x direction, towards positive infinity, towards negative infinity. For a hole, it's actually, the graph just looks the same, and it's just jumping over the top. If you put this in the calculator, you wouldn't see that show up on the graph, because it's just one infinitesimal little speck. It would look like the graph is continuous. If you went to the table of values, there would be an error for that value. But you wouldn't see it on the graph. Now you can see where this comes from. The zeros of the denominator, as we just said, is where we look for points of discontinuity. What are the zeros of the denominator here? 2 and 1, right? If I set this equal to 0, then I would say x equals 2 and x equals 1. Right? But notice that x minus 2 is a factor also in the numerator. So when I cancel those out, that's what gives us the characteristic whole. Right? When one of your zeros of the denominator is in a factor that cancels, that's where the holes come from. But for the most part, we're not interested in that. We're only interested in the ones that don't cancel out, because those lead to the vertical asymptote.